In order to solve systems of equations using matrices, which is the ultimate goal here, we have to use inverse matrices. So we need to know what the inverse of a matrix is. Now, first of all, you can only have the inverse of a square matrix. 2 by 2, 3 by 3, 4 by 4. You can't have the inverse of some non-square matrix. And so an inverse matrix is one where if you take the original matrix A and multiply it by this inverse matrix, and it doesn't matter which order you multiply them in, whether it's A, the original, times the inverse, or the inverse times A, you're going to end up with the identity matrix, which is a matrix that has ones on the main diagonal from the top left down to the bottom right, and zeros everywhere else. So in this first example, we want to verify that the two matrices are inverses. We're going to do that by multiplying them and seeing that we get that identity matrix. Ones on the main diagonal, zeros everywhere else. So, of course, it's always good to verify that we can indeed multiply the two matrices. So here we have a couple of 2 by 2 matrices, and our inner dimensions match, so our outer dimensions are going to be our result. And so for our matrix multiplication, when we multiply these two matrices, we're going to end up with a 2 by 2, so I'm going to build that template over here for our row by column multiplication. So I'm going to go across the row and down the column for row 1, column 1. So we've got 1 times -3 plus, and then I go across the row to 4 and down the column in B1 to 1. So we've got 4 times 1. Then I'm going to go to row 1, column 2. So I've got 1 times -3, or sorry, 1 times -4, and then added to that is going to be 4 times 1. Now I'll move on to row 2 of our first matrix. So I'm going to go across the bottom here and then down the first column. So -1 times -3 plus, and then across the row we've got -3 times 1. And then finally our last is row 2 times column 2. And so we've got -1 times -4 plus -3 times 1. And so if we perform those operations to end up with our resulting 2 by 2 matrix, here we've got -3 plus 4 gives us 1. We've got -4 plus 4, which gives us 0. Moving to the bottom row, we've got -1 times -3 is 3 plus -3 is 0. That's supposed to be a 0 there. And then 4 plus -3 gives us 1. And so indeed we end up with a identity matrix. Ones on the main diagonal from top left to bottom right, and zeros everywhere else. So these two matrices are indeed inverses. So how do we obtain an inverse matrix? So in this case here, we've got a 2 by 2 matrix A, and we want to find its inverse. So one option that we can use, and this is something that applies for 2 by 2, 3 by 3, any size square matrix, is we can write it as a double matrix like the one that we see here, where on the left-hand side we have the original matrix, and on the right-hand side we have the identity matrix. And so what we're going to do in a moment is we're going to perform a series of row operations to where we're going to be turning this side here into the identity matrix. So by adding the rows in such a way, we're going to turn it into that 1, 0, 0, 1. And then as we do that, the other side, this identity matrix, is going to turn into the inverse of A. So let's get started on that to see what it is that we're going to do. So I'm going to recopy what we have here. We've got 2, -1, -3, 1, and then we've got the separation here of the identity matrix. So what I mean by performing row operations is I'm going to be turning this left-hand side by somehow combining the rows, sort of like we do with elimination, in such a way that I'm going to turn this left-hand side into the identity matrix. And the sequence in which I'm going to go is kind of around in a counterclockwise circle. So my goal here to start off with is to turn this 2 right here into a 1 by somehow combining the two equations together, the two rows together. So one way that I can do that is I can take 2 times the row 1 and then add to it row 2. So that's the first operation that I'm going to perform. So what that means is the bottom row of my matrix is going to stay the same. I'm not doing anything to the bottom. So I'm going to go ahead and recopy that right away. But then in place of the top row, I'm going to take from right here, I'm going to take 2 times the top row, 2 times row 1, and add to it row 2. So I'm going to do that for each corresponding entry. So 2 times 2 is 4, plus -3 gives me 1. Then I do the same thing. 2 times -1 is -2, plus 1 from the second row is -1. Then I go over to the other side. 2 times 1 is 2, plus the 0 below it is 2, and then 2 times 0 is 0, plus the 1 below it is 1. So what I've done is I've replaced that top row with 2 times the top row plus the row below it. And so step 1, my goal was to turn this into a 1, because eventually we want to end up with just 1s on the main diagonal and 0s everywhere else. Step 1 is taken care of. So my next is going to be to work on this -3 right here. I need to turn that into a 0. So how am I going to do that? Well, again, I'll set things up here. Now this time my top row is going to stay the same. I'm not going to do anything there, so I'm just going to go ahead and recopy that. And 2 and 1. And so, but now I'm going to make some changes to this bottom row. And so I want to turn this spot here into a 0. So one way that I can do that by combining it with the row that's above it is I could do 3 times row 1 and then add to it row 2, because then 3 times 1 will be 3, plus that -3 will give me 0. So let's go ahead and do that. So we already established that we're going to have 0 in this spot right here by performing those operations. Then I'm going to multiply 3 times the -1 that's right here. So 3 times -1 is -3, plus 1, it's going to give me -2. Then I go to the other side. 3 times 2 is 6, plus the 0 below it is still 6. And then for the last column, 3 times 1 right here is 3, plus the 1 below it gives us 4. So we're making progress. We've got the 1 in the upper left-hand corner. We've got the 0 below it. So now we're going to keep on moving in our counterclockwise rotation, and we want to turn that spot there into a 1. So meaning this -2, we want to turn it into a 1. So I'm going to move this way. Now one thing that we can do is, instead of combining 2 rows together, we can always just divide a row by some constant. And so if I took this bottom row right here and just divided everything by -2, I would still have the 0 here that I want, because 0 divided by anything is still 0. The -2 would turn into a 1, which is what I want, and then I can just divide everything else in the row by -2. So that's what I'm going to do. I'm going to do row 2 divided by -2. So the top row is going to remain the same. So I've got 1, -1, and then on the other side we still have this 2 and 1. And then on the bottom I'm just dividing everything by -2. So 0 remains 0. -2 divided by -2 is 1. And then 6 divided by -2 is -3. And then 4 divided by -2 is -2. So we're getting close. We've got 3 of our elements of our matrix turned into the identity matrix the way we want it. The last thing we need to do is to turn this spot right here, this upper right-hand corner, into a 0. And so how can I do that? Well, hopefully we can see that if we were to add these 2 rows together, I would maintain the 1 here. I'd then be able to turn this spot into a 0. And then of course we would just leave the bottom row as is, and so then we'd finish and end up with our identity matrix over there on the right hand side. So I'm going to replace the top row with row 1 plus row 2. So the bottom stays 0, 1, and then -3, -2, and then row 1 plus row 2, so just adding those together, I get 1. Negative 1 plus 1 is 0. 2 plus negative 3 is negative 1. And then 1 plus negative 2 is negative 1. And so here we have identified our inverse matrix. So the inverse of this original matrix A is the matrix negative 1, negative 1, negative 3, negative 2. So this technique of row operations can be applied to any size matrix, 3 by 3, 4 by 4, 5 by 5, and so on. Now, fortunately, in the case of a 2 by 2 matrix, we do have a shortcut as to how we could find the inverse by hand. This doesn't apply to 3 by 3 or 4 by 4. The row operations method is the only way we're going to be able to find those, which makes us sad. But in the case of a 2 by 2, we do have a shortcut. And the way we apply that shortcut is to say, if this is our original matrix A, then I can take the elements of A and flip-flop on the main diagonal, so the D and A have switched spots. And then on the other diagonal, I just change the positive and negative signs of those entries. And then if I multiply all of those entries by the fraction that we see here, then we're going to end up with the inverse matrix. So it's just a formula that we can apply. So let's do that here. So if we want to find the inverse of A, I'm going to start off with that fraction here. So A times D, so running down this main diagonal, we've got 1 times negative 3 minus C times B. So now the other diagonal is going to be 4 times negative 1. And then we're going to multiply that fraction by, now I need to flip the numbers that are on the main diagonal as we see here. So negative 3 and 1. And then I'm going to change the positive negative signs on this other diagonal. So we're going to have positive 1 down here and negative 4 up here. So let's sort out this fraction here. So we've got 1 over negative 3 minus negative 4, so plus 4. So it turns out that we're just multiplying everything by 1. So in this case, here is our inverse matrix.